Hello, this is Jane Kim, a senior in robotics engineering technology. In this presentation, I will introduce my project, development of an open source mobile robot platform for multi-robot systems. Swarm robots and human-robot interaction are two hot topics in the field of robotics, but they are not widely discussed together yet. Swarm robotics, the use of multiple robots as a group to achieve a common task, allows individual robots to cooperate to tackle a bigger problem to smaller, manageable ones. Because of such advantages, swarm robots are expected to be used in public settings too, including door-to-door deliveries and aiding human workers in industrial environments. This human-robot interaction with swarm robots has caught many researchers' interest, and there are many algorithms and theories tested and proved in simulated environments. However, the platform to realize the study is often expensive, difficult to learn, or has limited capacity. For this reason, we wanted to create a low-cost, open-source multi-robot platforms for the researchers and educators. While planning to develop the platform, we had several goals in our minds. First, we wanted to keep the system simple, using only one mainboard computer and no additional microprocessor. This way, we could use only one programming language, Python in this case. This also allowed for easier integration of Robotics Operating System 2, also known as ROS2, which facilitates the communication between the devices. Also, we wanted the robots to be affordable, given that we would incorporate more than 10 robots as a swarm. Along with being affordable, the robots are made with more accessible parts that one would easily find in online stores. Being able to customize the robot was crucial for us too. Since we are planning to run experiments with the robots, they need to be adjustable to meet the different needs of each experiment. Hence, we designed the structure to be open for modification. We also wish to bring educational values with our robots, so we decided to go fully open source. Every bit of hardware and software is displayed and explained openly. The robot is 160 millimeters in diameter and 100 millimeters in height. The input sensors include a camera, 8 time-of-flight distance sensors, and 2 optical line sensors. Output devices include 2 DC motors and 4 RGB LEDs. The DC motors are controlled by L293D motor controller, TOF sensors are on I2C bus, and line sensors use MCP 3008 SPI ADC chip. The main processor, Raspberry Pi 4, utilizes ROS2 to control its input and output devices, as well as to receive commands from the main computer. Using ROS2 gives this platform huge flexibility by using nodes and topics. The nodes used for our robots could be divided into subscribers and publishers. Subscribers such as LED and motor nodes accept the values from the main computer and perform desired outputs, while publishers such as distance sensor and optic sensor nodes provide the collected data to the main computer. The electronic components are divided into 3 PCB layers. The first layer has an analog diode converter chip, line sensors, and motor driver. The second layer has TOF sensors and a mount for a Raspberry Pi. The third layer has RGB LEDs. It also has a placeholder to utilize additional pins in which users can add a customized shield or expansion board. To share our robot with the public, we have created a GitHub repository with a wiki page and every piece of information necessary to build our robot. This includes the CAD files, PCB files, codes, and instruction on how to solder and assemble the robot. Even though we provided everything needed to build a full robot, it will be puzzling for the user to figure out the configuration on their own. Therefore, we included a throughout instruction on how to build a robot, and examples of running each node. Following is a part of the video tutorial that will be made available with the GitHub repository. Those are the examples of the content listed in the GitHub repository. Those are the example applications showing the capabilities of the robot. In this project, we created a platform that is relatively cheap, open-sourced, and easy to learn. For our next step, we are planning to use the robot to conduct a user study on human perception of swarm robots. Existing literature suggests that colors and distance of the swarm could alter the perception of those who are watching them. Our goal is to first determine which parameters affect the user who interact with swarm robots in what way, so that we could conduct another study utilizing those parameters to minimize the discomfort of the users. Thank you for watching the presentation. Please leave a comment or email me if you have any question.